We're on our last topic for this semester, and that is statistical inference for two means. In the last few videos, we looked at inference for one mean, and we finished with this reminder that if we're doing confidence intervals or hypothesis tests, that is, making inference about a population parameter, we had this rule of thumb. If the parameter was a proportion, whether just one population proportion or comparing two, we used Z star using inverse norm for confidence intervals, normal CDF for the p-value. If we're talking about means, we had this new distribution, the t-distribution. So mean, use t, proportion, use z. Just a reminder there. All right, so talking about inference for two means, we're going to see a lot of similarities. And as a reminder, our symbol for the mean of the entire population is mu. Since we're going to compare two groups, we have mu1 minus mu2. So our confidence intervals, we'll start there, are going to be for this specific quantity, mean of group 1 minus mean of group 2. And similar to proportions, it tells us the same idea. If the difference is 0, that means the two groups have the same average. If the difference is positive, then group 1 is larger. If the difference is negative, then group 2 is larger. So let's look at the details. Confidence interval, we have our usual pieces, point estimate, plus or minus our margin of error. Hopefully you're saying this along with me in your heads now, and margin of error has the same two pieces, our multiplier for level of confidence, and standard error that takes into consideration that our point estimate would vary from sample to sample. So if our goal is to estimate mu1 minus mu2, what we're going to start with from the data, or our point estimate, is going to be x1 bar, the mean of the data for group 1, minus x2 bar, the mean of the data for group 2. Then our multiplier, remember our rule, if we're talking about means, we're using the t-distribution, so our multiplier is going to be t star. And I'll add a little comment in a moment on that. And then our standard error, if you remember for one group, it was s over the square root of n. Now I'm just going to expand that to consider the variability for two groups. So s1 squared over n1, so that's the standard deviation, make sure to square it, for the first group over the sample size for the first group, and then s2 squared over n2, the variability coming from the second group. So notice n1 and n2 can be different. I can have two different sample sizes. If you remember, to find the multiplier for the t-distribution, we used n minus 1. There's actually a really complicated formula for a nice degrees of freedom here. We're not going to worry about that. To get a conservative estimate, we're just going to still use that idea of n minus 1. But if you have two different n's, we're going to go with the smaller of the two. So here I'll say where degrees of freedom is smaller of n1 and n2 minus 1. And you'll see in an example. So just still think of n minus 1, just choose the smaller n to use. And remember, t star we got from either using inverse t or your table if you don't have inverse t on your calculator. Now let's look at the framework for our hypothesis test. We have the same general setup. First we need to state our hypotheses. We still have two of them. Our initial assumption in the null and our research claim in HA. Since we're talking about two means, we're going to use the notation mu because our claim is about the whole population. And we're going to call them mu1 and mu2. Just like always, the null's going to have an equal to sign in it. So we're going to start off assuming there's no difference in the two groups. They have the exact same average. Our research question, we think something's going on. The groups are different. So we might think the first group is less than, maybe greater than, or somehow just different than group 2. So one of those is our research question, depending on the context. So you may write your hypotheses this way, or you may write them as differences. If mu1 and mu2 are the same, That's the same as saying mu1 minus mu2 is 0. And then in HA, just subtract mu2 from both sides. So that's the same as saying mu1 minus mu2 is less than 0, greater than 0, or somehow just different than 0. You don't have to write both versions down, just choose which one you like best. All right, so hypotheses, similar to what we've seen before. Now we need our test statistic. So remember, this is t-calc. We're dealing with means, so t-distribution, not the z-distribution. And remember our general formula. It's our data, or evidence, our point estimate, minus the initial assumption over our standard error. Looks like a z-score. So same thing here. Our data is how different are the two groups based on the averages from the data I've collected. So x1 bar minus x2 bar, that's the difference represented in the data. I'm going to see how far off this is from my initial assumption or the null hypothesis. So mu1 minus mu2. If you notice over here, the null says mu1 minus mu2 is 0. They're not different at all. So this second term is actually just 0. You don't even have to write anything here if you don't want to, but I like to because it emphasizes the idea that we're still measuring what the evidence from the data shows versus the initial assumption of no difference. The standard error is the same one we wrote down above, the variability contributed by the first group plus the variability contributed by the second group. Be careful of your handwriting, make sure this is all under one big square root. And then, for our p-value, just as a reminder, because we're talking about means, we're going to use t-CDF, and we use it in the same way that we've used it before. So I'm just going to say use t-CDF. I'm not going to write out the details. And then the last two steps, our interpretation of the p-value and our conclusion, are going to be exactly the same as they've been for all our different hypothesis tests. All right. So make sure you have that down. If you want to try the next example before watching the videos, go ahead. In the next videos, we'll work it out and see how you could do.